Very good morning to one and all. This is Satyanarayan speaking from the VA Solutions. So I am the resource person who is going to handle for the today's session. So I hope today's topic will be on the data acquisition hardware. Okay, the DAC hardware. So we'll be just let know how this data acquisition hardware, the in and outs of this hardware. So we'll be just going through the MyDAC hardware thoroughly. Okay, so we'll not just waste the time. We'll just going to start the session. Okay, so I'll just try to present my screen. Okay, so before getting into the presentation of the screen, so I'll be just let you know about just the introduction about the hardwares. Okay, so I hope you people will be knowing about the hardwares, and you will be also working about what kind of a hardware. So in engineering sections, right? So we'll just know about a brief introduction about the hardware. Okay, so what exactly the hardware? So why we have to use the hardware for the things, right? So that is what our question. Okay, even students also might ask like, so what exactly the hardware? Why we have to use the hardware? Okay, so we'll just know about the hardware, like the introduction about the hardware. So hardware refers to an the interconnected electronic component which performs analog or logic operations. Okay, on received with a local stored information to produce output or to store which resulting in a new information. Okay, so what I mean is like hardware is an interconnected electronic component, means nothing but like hardware will be connected to one of our system, like either it may be a laptop or a PC. Okay, or directly connected to the AC mains, right? So which performs logic or analog operations. Okay, so as we all know that the hardwares will be worked under the logical part, like the digital or analog sections. Okay, so which receives the connections from different external sensors, right? So which produce the output, and even some sort of a hardware can able to be stored, okay, with the information whatever we provide for them, right? So that is what the hardware exactly. Okay, so we are nowadays we are using a different sort of hardwares, right? For just I'll be just giving you the example. Okay, so if you take a mobile phone, right, the cell phones whatever we use in our daily life. Okay, so even we call that as a hardware. Okay, so why we call that as a hardware in the sense, so we are just trying to give some sort of an input. Okay, like to unlock our screen or to just capture a photo or to just download some application. So we'll be just trying to give some sort of an information, like the input for the hardware. Okay, so based on the information, it relatively give back some sort of output. Okay, so either it might be an capturing a picture and storing it in a memory. Okay, either it may be internal memory or external memory. Okay, based on the cell phones what we use, right? So and based on the sensors like touchscreen sensor. Okay, so or unlocking sensors. Okay, some different sort of a sensor. Based on that, okay, we'll be giving some sort of an input. So relative to that, we'll be getting some output. Okay, that is what exactly the hardware. Okay, so that's what I just given you the example, related to the hardware part. Okay, so next we'll be just getting into the hardware part. Okay, means the NI hardwares, what all the NI hardwares we'll be using. Okay, so I'll be just sharing my screen. Yes. So can anyone please acknowledge me that can you able to see my screen?
Yes, sir. It's visible.
Yeah. Okay, sir. Thank you. So Yeah. So, based on the today's topic, okay. So, this is like whatever you are right now you're seeing on my screen. Okay. So this is what National Instruments, MIDAC hardware. So, actually part is it is an student-based hardware. Okay, like basically, okay, it's somewhat like it will be used for the students, like engineering students, so they can be used starting from first year itself. Okay, so what exactly this hardware? Okay, so what is the uses of this hardware? What are the applications? Okay, so what is the speciality of this hardware? Why we have to use this, and how this will be used for the students? Okay, so either it might be in their career as well as in their engineering core subjects. Okay, so what effective, how effective this hardware works. Okay, so all those things will be just seeing in today's topics. Okay, so basically I just told you that it is an the National Instruments hardware. This hardware name, we call that as DAQ. Okay, so DAQ stands for data acquisition. Okay, so this hardware is only meant for acquiring the data. Okay, fine. So here on this hardware, it's very compatible. Okay, so what are the hardware you're seeing right now on my screen? Okay, it's very compatible. Okay, it's somewhere like we can say it's like by carrying like a two mobile phones. Okay, so or even a single mobile phone, like, okay, even you can just try to carry this hardware on your pocket itself. Okay, so it's very delicate, or it's very compact hardware designed by the National Instruments. Okay, so why they have been designed this hardware? Okay, so usually we'll be seeing that we are having a number of hardwares, right, in in your college laboratory. Okay, so we'll be having a number of hardwares like function generator, oscilloscope, right, regulated power supply, so etc. Like you will be having some sort of different sort of hardwares. Okay, this sort of hardwares we'll be using in our laboratory. Okay, such kind of thing. Similarly, how overcome this MIDAC hardware can be used in your labs. So how it will be effective, or how it will be impress the students so that they'll be very much engaged in their experimental things, right? So that is what the ultimate point. Okay, so this hardware is meant to use for the data acquisition device. Okay, so where you can able to generate some sort of a signals and you can able to acquire it back. So similarly you can able to connect some sort of external sensors. Okay, external transducers or external sensors can be connected to this sort of a hardware. So related to that, it can be worked both on analog as well as a digital part. Okay, that is what they really mean, right? So it can be worked on analog part as well as a digital part also. Okay, so we'll just try to come with the user guide. Okay, so what exactly this hardware? Okay, so what all the necessary things can be done? Fine. So actually speaking, okay, this student data acquisition device, what we call that MIDAC. Okay, so it combines a comprehensive set of plug and play computer based lab instruments. Okay, so usually we call this as the plug and play computer based lab instruments. So why you can just ask me that it's somewhere like you can just directly plug in to your laptop or into your PC, like how we just seen some of the plug and play devices, right? So as soon as you just plug in, so it starts working along with it. Okay, so but the main thing what we have to concentrate is, so before using this MIDAC, right, so before using this MIDAC, we have to make sure that we have to give a proper set of softwares as well as a device drivers. Okay, so actually speaking, you have a two set of the softwares as well as the drivers. Okay, so first one is, so must and should you have to use a LabVIEW. Okay, so the version does not matter here. Why? Because the LabVIEW has n number of versions like 2016, 17, 18, 19 as well as 20 also. So right now the updated one as well as a recent the LabVIEW software will be the LabVIEW 2020. So still 2021 has not yet been released. Okay, so maybe the latest version what I can tell is the LabVIEW 2020. Okay, so that's what I said you. Version does not matter it here. Okay, so ultimately you have to use a proper set of the LabVIEW. Either it might be a 32-bit or 64-bit. Even that does not matter. Okay, so you have to give a proper install a proper LabVIEW software. So secondly, you have to install the driver. Okay, so and main thing here we have to concentrate is, so if at all you install, for example, I'm just saying for example, so if at all you are trying to install LabVIEW 2018, okay, so as your main application software, okay, so you have to must and should use a device driver software as NI Elvis 1800. Okay, so I'll repeat once again. So if at all you are using the LabVIEW 2018 software, if at all you're using this, so you have to must and should use a device driver software of NI Elvis 1800. Or if at all you are using LabVIEW 2019 or 2017 earlier version, so we have to use NI Elvis 1700 or 1900. So based on the LabVIEW version, LabVIEW application software what you use, you have to accordingly you have to use a device driver. Okay, why this this sort of a thing is mandatory? Why? Because so based on the software, LabVIEW software, whatever we are using, so according to that the device driver will support. Okay, so at that particular point of time, so you can easily access this hardware. Fine. So this is what the software requirement to use this particular set of a hardware. Okay. So since I have told you that it is combines a comprehensive set of a plug and play computer based lab instrument. Okay. So since instrument, even this hardware also comes under the instrument. Why? Because so even you can use a function generator, you can use oscilloscope. Okay, so some different sort of features and functions are available. So maybe I'll be continuing the same. Like I'll be explaining you what all the features and what all the applications you have in this NI-based hardware. Okay, so these instruments with probably and the hands-on students learning in their lab or outside a lab also. Okay, so that is what the main advantage of using this hardware. Okay, so I can just give you a simple example. So think that one of a student, they are developing some simple project based on function generator and oscilloscope. They're just trying to rig up some circuit. Okay, so based on that circuit, they'll be just working on function generator and oscilloscope, right? So they'll be just taking some inputs as well as they are measuring some sort of output with volts per division, time per division. Okay, so related to the circuit whatever they have been rigged up. Okay, so if they want to use if they want to use any sort of the circuits. Okay, so they are obviously they have to come for the lab. Why? Because so we cannot carry the function generator or oscilloscope to their home, or they cannot try to use it outside of the laboratory. So why? Because it's totally the wrong decision what they are going to take, right? So even the management also will not agree to take off their function generator or the instruments whatever they are using in the lab. Okay. So, but at that time, so maybe if they are capable of using their hardware with the whatever the circuits they rig up. Okay, surely if this hardware, this set of hardware like NI DAC or you have a C DAC, okay, you have a CRIO, okay, all these things will comes under the data acquisition things, right? So if they are capable of doing, some certain sort of a research or any of the of their own project, okay, so obviously they can use this sort of a hardware. Okay, so if they are trying to rig up their own circuit and they are only measuring, the voltage or the current with respect to voltage generator, function generator or voltage generator. Okay, so these sort of things can be even work with MyDAC. Okay, so maybe like in afternoon session, I'll be just showing you the demo, like how you can able to generate the signal, how you can able to get, acquire the signal, or maybe from external sensor, how you can able to acquire, the signals or the values. So maybe these things will be just seeing in the afternoon session. Okay, so today in the first session we'll be just trying to discuss about the hardware, what all its advantages, applications. Okay, so all those kind of stuffs will be going in the first session. Okay, so just we'll just come back to the that example, whatever the students, they are just trying to work. Okay, so even they can just take this hardware out of the lab, or even they can just sit and work within in their classroom itself on their place, whatever usually they'll be getting into the theory classes. Okay, so they can just trying to connect very easily. Why? Because this hardware, MyDAC hardware, does not contain any power sources. Okay, but usually if you just see, if at all they are using the function generator or oscilloscope, obviously it needs 230 to 250 volts AC power mains, right? So, but this hardware, whatever the hardware, MyDAC hardware we are using, this does not want any power sources. Okay, so then you can just ask me, sir, then how it will be work? So without giving any sort of a power, so how this hardware works? Okay, so that is what a question. Yes, obviously it will be working. So previously I was just showing you the picture of a DAC. Okay, so here you can just see, obviously if the word, if I say it's a plug and play, obviously the one thing will come to your picture. Either it will be run in the battery, okay, so or it will be run with an some other type of like a USB or a C type cable or some other thing. Okay, so yes, obviously it will be powered up with a USB cable. Okay, so you can just see here the USB cable, whatever it's been connected to the hardware. Okay, so this USB cable will be directly connecting into your laptop or a PC, where you will be inserting your hard disk or a pen drive, external devices. Okay, so this USB cable, okay, will be directly connected to the laptop or the PC, which the system you have been already installed the LabVIEW as well as DAC drivers. Okay, so that is mandatory always. So before using the DAC, so make sure that you have to be very careful, and you have to be use the necessary software kits, so that you can just start use the software very the hardware very easy. Fine. So this the cable, whatever the cable, USB cable we connect. Okay, so obviously we all know that whatever the USB part will be connecting, obviously it will be flowing some sort of a voltage, right? So it will be works under the 5 volt. Okay, so even this hardware, whatever the hardware we are using, this will be worked under the 5 volt, but instead will be choosing some sort of the converters or current limiter. Okay, so or voltage booster, amplifiers. So all these circuits will be used here. So I'll be just showing you that the circuits, whatever they have been used. Yeah, so you can just I hope everyone can see these circuits. Okay, so what all the necessary things, how this hardware is very compact, or what all the very minor minute circuit they have been used. Okay, so you can just see here. So first, as soon as they connect to an USB connector, okay, so the hardware will get powered. Okay, so that is what I said, that this hardware is plug and play, right? So as soon as you have been connected to the USB connector, So first it will check for the circuit protection. Okay, so why it will check for the circuit protection is nothing but, okay, so why? Because even I told you that it will be works for under the 5 volt. Okay, so why? Because the USB port, whatever we are getting out from our PC or the laptop, will be the 5 volt. Okay, so it will just checks for whether you are getting a proper circuit, proper voltage, necessary voltage to work with the hardware. So if so else, then it will be just going for the current limiter. Okay, so and even I told you that we have they have been used some sort of amplifiers and regulators. So why? Because to just boost up the necessary voltages. Okay, so since here you are having one advantage is that think that if any of the circuit wants more than 5 volt or a 10 volt or up to 15 volt. Okay, so here using the voltage regulators, so it can just generate a voltage from minus 15 volt to plus 15 volt. Okay, so I'll just repeat once again. So if any of the students want, they have rigged a circuit, and if they want to work with some sort of the research works or their project. Okay, so if they want to use some external voltage apart from 2 volt, 3.3 volt or a 5 volt. Okay, so obviously they have to go with power supply, external power supply, right? So instead of using the external power supply, like for 5 volt or a 10 volt or maybe maximum 15 volt, so instead of using external power source or power supply, so they can be used this DAX pin out. Okay, so it can be worked, means it can able to generate an external power from minus 15 volt to plus 15 volt. Okay, so and even they have by default it can able to generate up to 5 volt. Okay, so this 5 volt as well as minus 15 to plus 15, these are all the power sources for a DAC. So why? Because obviously whenever we try to use any external sensor or any external transducer, obviously it needs a power as well as a ground. Okay, so minimally they'll be using 3.3 volt or maximum it may go for 5 volt. So any another some electrical circuitry which may extend up to 5 volt or maximum it can go with 10 volt, okay, or 15 volt. So using this external power supply like plus or minus 15 volt as well as a 5 volt, so they can be used through the wire. Either they can go with a single strand wire or the multi-strand wire. So they can use this as an external power supply. Right. So then coming to the next part, like the I/O pins, whatever I told, it can be worked in analog section as well as the digital section, right? So here you can just see they have been using the multiplexer as well as a converter, A to D converter or D to A converter. Okay, why? Because so whatever we can deal with some sort of a sensor in analog section, or some sensor will be deal with the digital section. Okay, so both analog as well as digital sensor can able to be worked. Okay, so for that sake, what they are doing is they are just trying to go with analog to digital converter and digital to analog converter based on the sensors we will be connecting. So those things will be directly connected to the channel multiplexer, and along with the channel multiplexer, you can able to connect with your analog or the digital pins. Right. So next, coming to the one more section. So you have you can able to work with a digital multimeter. Okay. So anyhow, in the analog communication lab or the digital communication lab, so obviously the students will be using the multimeters, right? So why? Because to just know what exactly or where exactly they are getting a proper voltage, or the voltage whatever they have been supplying from the external power supply, so is getting a proper voltage, or whether the IC is working properly, or many like different sort of things. Usually they'll be using a multimeter. Okay, so even in this MyDAC, okay, in this MyDAC we are using a digital multimeter. So where we'll be just trying to connect a probes. obviously how we'll be connecting to a multimeter, digital multimeter. So similarly, we'll be having options to connect probes, and you can able to measure a voltage as well as a current to some restricting level. Okay, so even I'll be just showing you in the specification. So what will be the maximum voltage or maximum current that you can able to be measured here. Okay, so I hope you will be clear about this. The circuit part or circuit connection, how compact it will, it is, and what are the features you'll be having. And moreover, you are having one more additional feature will be the audio. Okay, so in this MyDAC, you can able to work with the audio. Okay, like audio input or audio output, where you'll be able to feeding some sort of the sound or some noise to a MyDAC. So based on the sound or noise whatever you are being given, so it will be processed. Okay, and ultimately you'll be getting some sort of the same noise or any other outputs. Okay, so even maybe like while giving the demonstration, I'll be just showing you all those features like audio input, audio output, or digital multimeter, or based on the analog or as well as the digital, how the things are being working or using with this DAC applications. Okay. Fine. So maybe I hope you got some the idea on the DAC. So what all the things can be used in the DAC. Okay. So all those things features have been there in this DAC. So that is where like we call this as multifunctional equipment or multifunctional instrument. Okay. Fine. So coming back to the specifications. Okay, so right now we have seen what all the things, what all the hardwares that have been used inside, like on the DAC or inside the motherboard. Okay, so now we'll just see what all the specifications or what are the features on the DAC. So even I told you that we can work with the analog part as well as the digital part. So later part will I told you that we can just work with a multimeter, okay, as well as the audio in and audio out, right? So all those things will coming back to the features. We'll be just knowing what is the voltage range, input as well as output voltage range, the sampling rate. Okay, so we have to know why, because if at all we are trying to deal with any sort of a hardware, so first of all we have to know what all its the specifications. So without knowing the specification, we just cannot directly get into the hardware. Why? Because so we'll be not knowing what pin is meant for what, right? So so we have to know first about the data sheet, right? So we have to first know about the data sheet. So later part we have to just get into the hardware. Okay, so this is what the data sheet of the analog, the MyDAC. Okay, so first we'll just go with the analog section. So later part we'll just go for the digital. Okay, so first going to analog input. Okay, so in this analog input we are having two differential analog input. Okay, so why? Because even when we are trying to deal with any sort of a hardware, so we have to know how many input, like how many analog inputs or how many digital inputs or a digital output will be having. Why? Because so based on our requirement, so we have to choose the hardware. Okay, so since I have told you that the MyDAC hardware, it's a student's student based hardware where they'll be working under any research or any projects. Okay, so here for this set of hardware, MyDAC hardware, we are having two differential input. Okay, we are having two differential input and one stereo audio input. As I told you that we can able to deal with the audio input as well as the audio output. Similarly, so that comes under the analog. Yes. So why? Because whatever the audio, whatever I'm speaking to you right now will be comes under the audio, right? The analog section means whatever I'm just trying to speak to you or whatever I deliver to you. So whatever you are hearing, so will be comes under the sinusoidal wave. right? So that's why the audio will always comes under the analog part. Fine. So since I told you that we are having two differential channels and one stereo audio input channel. Okay. So and it works under the resolution, like analog to digital converter resolution will be the 16 bits. Okay. So it works under the 16 bits, or even we can just tell that it will be works under the 2 bytes. Okay. So if they ask like what is the resolution of the hardware, so obviously you can just tell them it is a 16 bits, or you can go for 2 bytes of hardware. Okay. So and what will be the sampling rate? Okay. So obviously we'll be knowing about the sampling rate, right? So if the sampling rate is high, so we'll be just getting a more accuracy, or we can easily say that whatever you are trying to acquire the signal it back, so it will be in very the fine quality, we can just say. Okay. So even here also it's actually saying it's a fine quality. Why? Because it is it can consist maximum sampling rate will be of 200 kilo samples per second. Okay. So we can easily say that it whatever we are trying to acquire it back from any sensor or any transducer, okay, it will be very accuracy. The accuracy will be high. Okay. So if you want much more accuracy, saying that you will be having any thermocouple hardwares or any about the sensors, if at all you want to measure it very accurately, so maybe we have to go for the higher end hardwares, like previously what I said, the CDAC, CRIO, okay, PXI, PCI. We are having a different sort of data acquisition hardware from the National Instruments. Okay. The CDAC stands for actually the compact DAC, compact data acquisition hardware. Actually speaking, CDAC will be used in an industries. Okay, so industries or the research projects or any such kind of thing. Okay, so they'll be using this sort of a hardware. Why? Because they need whatever the sampling rate we are using in a MIDAC, 200 kilo samples per second, will be actually very low compared to the industrial part. Okay, but if you just think about the student part or a student end, so this 200 kilo samples per second, the sampling rate will be more than enough for them. Okay. So why? Because they'll be just working under the engineering concepts or the core subjects, whatever they undergoing, like the signals and system, control systems, analog communication or digital communication. So they'll be just working under these follow-up subjects. Okay. So I hope using this 200 kilo sampling per second, the sampling rate will be more enough for the students to be used. But if at all you come for an industrial part, okay, so obviously this 200 kilo samples per second will be very less. So they'll be obviously they need more than 500 kilo or more than 800 kilo samples. Okay, so that's why they'll be upgrading to an the CDAC or a CRIO, PCI or a PXI express systems. Okay, so and here the time accuracy also it's very minimal, like they are given like 100 ppm of sampling rate. Okay, so and timing resolution is very much important. Why? Because whatever the hardware we are using, okay, obviously we'll be having what we say the timing clock. Okay, so even for our PC also, and even for laptop or even for our cell phones, whatever we're using, we'll be having a system clock like 2 gigahertz or 2.2 gigahertz or 3 gigahertz, the hardware timer. Okay, so those things also will comes into the picture. But since it's a very compact hardware, they are given very less time. The time resolution will be the 10 nanoseconds. Okay, so even these things also will comes into the picture. Right. So next, coming back to the range. Okay, so in the range we can easily say what will be the range. Okay, so sir, since we are trying to power up with the 5 volt. Okay, so we'll be using analog as well as digital. Okay, either we'll be using analog or either we'll be using digital or both parallelly. Okay, So we have to know what will be the voltage range. Okay, so in an analog input, the voltage range will be the plus or minus 10 volt. Okay, means where up to minus 10 volt to plus 10 volt, you can able to vary with your the voltages, as well as what all the sensors we will be using. So first we have to know about the voltage ranges. Okay, so till what voltage it can able to generate, or what voltage will be the power line. Okay, so those things will comes into the picture. So, and with respect to analog input, it will be plus or minus 10 volt. Okay, and with respect to audio, if we come for the audio section, so it will be the plus or minus 2 volt. Okay, so why? Because in analog input, okay, we'll be using some external sensors, so that it will be needed with larger number of voltage range. So that's where they have been designed in such a way that so it can able to go with minus 10 to plus 10 volt. But if you just try to come with audio, so for audio, I don't think so we'll be connecting any sort of sensors, right? So we'll be just trying to plug up with audio jack, and we'll be just start playing the music. Okay, so that's why this voltage range will be the plus or minus 2 volt. Okay, and the connector terminal, whatever you can just see here, the connecting terminals. Okay, so here the black color, whatever you can just see with above that, it will be having the screw type of terminals. Okay, so this will be the connector jack. Okay, where you can able to connect the single strand wire or maybe the multi-strand wire. So, but I recommend to use a single strand wire instead of a multi-strand wire. Why? Because the voltage or the capacity, whatever you will be able to pass from your sensors or any of the loop back circuits. Okay, so it's better to go with the single strand wire instead of a multi-strand wire. So if at all you are trying to use a multi-strand wire, so there will be a possibilities of a voltage drop. Okay, so that's why I recommend better to use with a single strand wire instead of multi-strand. Okay. Right. So, and audio input will be like 3.5 mm stereo jack, like whatever we'll be using for our headphones, 3.5 mm jack. So the same jack can able to be used into the analog input. So next, coming over to the analog output part. Okay, so in analog output, we are having two grounded reference. Okay, so in analog input also we are having the two channels, and analog output also the two channels. So ultimately we can easily say that in analog input we are having two input channels and two output channels. Okay, excuse me. So two analog inputs we have already seen, like what is the voltage range, what is its capacity, the resolution, okay, the timing, everything. So we'll just see about analog output. So in analog output also we are having two grounded reference. Okay, the differential. In input we are having a differential, and in analog output we are having grounded reference. In simple form, like how I can say is differential end in the sense like obviously whatever the input or you're trying to pass from your sensors. Okay, that sensors input should be always be grounded. Okay, so without giving a proper grounding, so you will be not able to get a proper output. Okay, so that's why for analog input it is giving a differential end, so where both the positive as well as negative should be connected. But whereas for analog output, so it is only the single line it has been passed from the sensor where you'll be able to generating the signals. Okay, so maybe while just giving the demonstration, I think you will be able to understand what all the things. Okay, so even for analog output, you have having DAC resolution will be the 16 bits, whereas in analog input you are having ADC. Okay, so in that even both are same, and even the update rate of this analog output will be 200 kilosamples per second. The same. Okay, so even the output voltage ranges will be like plus or minus 10 volt, like how we have been seen in analog input, and where the audio output also will be like plus or minus 2 volt. Okay, and maximum output current, where you can able to measure the maximum output current, will be up to 2 milliamps. Okay, so why? Because it's very compact hardware, as well as they're just trying to pass only the 5 voltage of input for the DAC. So that's why they're just trying giving a very minute current, where you can able to measure from the DAC hardware. So, but if you want to measure the more number of a current, like output current, obviously we can just do that, but not by using this the basic hardware, but instead we can able to go with the CDAC, or you'll be having a different sort of a modules, okay, like a voltage module, the current module, okay, or thermocouple module. So you'll be having different sort of a modules. So there the rating will be very high. Okay, so since it's a compact device, so that we cannot measure the very larger current or a very larger voltage. So instead, like somewhere in the minute part, these things can be done. Okay. So next, coming to the digital IOs. Okay, so actually we are having the 8 DIOs, like 8 digital input output pins are available. Like not exactly 8 input and 8 output. No, not exactly like that. So totally including input as well as output, it's totally 8. Okay, so how it's been designed in such a way that, so what all the lines we are having, the 8 input lines, it can be worked either input or either output. Okay, so all the 8 pins can be used totally for the output, or all the 8 pins can be used totally for the input. Okay, so it is designed in such a way that each and every pin, okay, has been designed in such a way, so it can either use for input or either it can be used for the output, based on the user, like based on the programmer, how he programs or how he selects. So based on that, you can able to generate or acquire the things, right? So, and here that's what they are given, the direction control. Each line individually programmable as input or output. So it can be accessed either in input or in output. So that's what the thing I told you. The programmer has to program. Okay. So, and here the logical level, like what will be the voltage range for the digital. Okay, so it is 5 volt compatible. Okay, and as well as 3.3 volt will be for the output, and 5 volt can be provided as an input. So it can be selected individually, means it can be toggled individually. So based on the programmer, how he programs. Okay, so the voltage range for input will be the 5 volt, and output will be for as 3.3 volt. Right. So even you have the counters. Okay, so if you just hear about analog as well as a digital, obviously you'll be having one more option called a counters or a timers. Okay, so here we are having one counter or timer. Okay, so what we call the PWM, pulse width modulation. Okay, so this is actually connected for DIO pin number 3. Okay, DIO pin number 3 can be worked as digital input or output, or even it can be worked as counter or timer. Okay, so even the resolution will be for counter or timer will be the 32-bit. Okay, so the internal base clock will be the 100 megahertz. Okay, so they are just trying to give some sort of more observational on a PWM, like the counters. So instead of DIOs. Okay, so in this hardware we can just use only a single PWM, like the counter. So if we want to go with more like 3 or 4 or 8, so maybe you can just upgrade our hardware to Rio systems, or the industrial DACs. Okay, So these sort of hardware, obviously they'll be having a more number of inputs and more number of outputs. Okay. So as of now, we'll just see about this MIDAC hardware, where it just consists of 8 DIOs, two analog inputs and 2 analog outputs. Okay. So then next come to the digital multimeter. Okay, it's one more feature of the MIDAC. Coming back here, so what all the things can be measured? Okay, that is the question. So here you can just see, you can just measure the DC voltage, AC voltage, DC current, AC current, resistance, diode, and continuity. Okay, so almost all the features, whatever we can just use in our digital multimeter. So these all things can able to be measured in the MIDAC system also. Okay, so what will be the isolation level? Like what will be the maximum level? Will be up to, it can withstand up to 60 volt DC. Okay, either DC current or the thing DC. So it can go up to the 60 volt. When you come for the AC, so maybe it can be worked with up to 20 volt. Okay, that is what maximum cutoff. So it cannot be go beyond the limits. So why? Because obviously inside a MIDAC you'll be having a fuse. Okay, so if you go on with a beyond the limit, obviously the fuse will burn. So it will not damage to any of your circuit, external circuit or the inbuilt circuit, whatever the DAC consists. So it will never harm for both. Okay, so that's why it's always better to go with proper data sheet or proper specification, so that we can able to measure it proper. Right. So this is with respect to the MIDAC. Okay. So I'll just try to connect the MIDAC to my system. Okay. So before connecting to the system, okay, so actually we have to know about one more function called the application called NI Max. Actually speaking, so this NI Max is nothing but it's a measurement and automation explorer. Okay, so where we'll be using this set of the application for whether to check whether our hardware has been properly connected to my system, whether it can be accessible. So all those things can be able to be checked under this measurement and automation explorer. Okay, so even though if at all you're working with any sort of industrial hardware apart from MIDAC, MyRio, so even those this NIMAC like measurement explorer automation will be very much useful. So it's taking some time to open. Yeah. Okay, so here this measurement and automation explorer, like whenever I try to attempt to open that, so first it will be just showing you, what all your system requirement. Okay, so this is actually my system requirement, and memory also it can be tell what all the things the system exactly you are working on. Okay, so this is what the entire about the my system. Then if you want to check any hardwares like external hardwares from National Instruments, whether it's been connected properly or not, so it's better to go under the devices and interfaces. Okay, so if you just click on here about devices and interfaces, so here you will be able to know what all the hardwares you have been connected. Okay, so I'll just use the magnifier so that yeah. So here you can just see, so this obviously this input inbuilt camera will be connected, so even the camera also will be detected. So and here if you see, like previously I have been I have been simulated this PCI, NI PCI 6289 and PXI 6221. So this these two hardwares have been simulated. So even we can able to simulate this MIDAC. Okay, but only thing is you can just simulate, you can just work about the MIDAC, like you can just see about what all the applications or what are the features we are having. but ultimately we'll be not getting the proper output or exact output. What the hardware what the hardware from our hardware we are getting. So we'll be not getting the exact output, but instead we can just see the options or see the features, what all the things we have been done. Okay. So now I'll just connect my MyDAC to the PC. Okay, you can just observe here. So I just connected now. Okay, so now it's been automatically searching, and here you can just see the NI MyDAC within the codes MyDAC1 will be connected. So and here also you can just see the settings, who is the vendor and the hardware serial number, the status is present. So previously, if you just see, if I just try to remove the hardware, okay, so it immediately disappears. Okay, so if you just try to connect it, okay, so it will be showing that it's a present. Okay, this is the only one way where you can able to check any of your student-based hardware or the industrial-based hardware, whether it's been connected properly or not. So actually, this is only one way. Okay, using the NI Max. So after connecting the hardware, so you'll be getting one pop-up window. Okay. So actually speaking, this is where one more like option where you'll be getting whether your hardware is detected properly or not. But sometimes, if any loose connections or if any the USB ports have been damaged, so even you'll be getting only this window, but you cannot easily say that my hardware has been properly connected to my system. Okay, so here now what I'll be demonstrating you will be first, as soon as I just try to connect my hardware, first I want to know how to check whether all the ports or all the pins are working fine. Okay, so for that what I'll do is I'll be just using a test this device option. I'll just click on go. So before getting into any sort of a hardware, so first make sure that we have to check the hardware properly, or we have to know all the pins have been working good. Okay, so here you're having some portions whether it's being connected properly, the connection establishment have been done properly, or all the pins have been done. Okay, so before checking this, make sure that what we have to do is we have to connect a proper connections, means the wire connections. So I'll be just showing you what all the connections I'll be doing. Yeah, so here like what all the connections I'll be done. So I'll be just showing you here. Yeah. Yeah, I hope you can just see here. So actually speaking, these are the pins we'll be using in the MyDAC. Okay. So totally overall, the entire pins will be the 20. Okay, we are having 20 pins. So in that, it's been individually, given the label like to which pin what you're supposed to connect. Okay, so starting from the first, from our left hand side. So as I told that it's having a voltage, a power supply. Okay, so plus 15 volt to minus 15 volt. So you can just connect for first pin as well as second pin for plus 15 to minus 15, and you have having the AGND, analog ground. Okay, so totally 2 analog grounds are available in the MyDAC. So and you are having AO. AO is nothing but analog output, AI is stands for analog input. Okay, so where under analog output you are having two channels, so AO0 and AO1. So you can just see here 0 and 1 stands for AO0 and AO1. So two analog output channel. And again, if you come for analog input, so you're having here also the two channel AI0 plus and AI1 plus. So since I have told you that for analog input, it is having a two analog input with the differential end. So that's what I said. The differential end is nothing but whatever the positive end you are connecting from either from the sensor or any circuitry part. So obviously the one more end has to be grounded. That is what the differential. Okay. So if at all you are not giving a proper grounding part, so there is a chances of losing the data, or there is a chances of not getting a proper output. Okay, so that's why they are given 0 plus 0 minus, 1 plus and 1 minus, but 0 plus and 0 minus are one channel, and 1 plus and 1 minus will be the another channel in AI. Okay, so next coming back to DIO. Okay, so you are having 8 DIO starting from 0 to 7, so totally 8 DIO. So each and individual pin will be either input or output. That can be done using the programmatical manner, right? So next you are having the digital ground. So where if at all you are using any digital the DAOs, so digital sensors where you can able to ground in the DGA. Okay, and last one more power supply you are having like plus 5 volt. So totally 3 power supply will be there: plus 5 volt, plus 15, minus 15. Okay, and two analog inputs, two analog outputs, totally 8 DAOs. Okay, so these are the main pinouts here. So now to check here, if whatever I have been opened, to check here, so what connection I'll be making is, so I'll just take one wire and I'll be start connecting to AI0 plus. The one end will be connected to AI0 plus, and the same another end will be connected to AO0. Why? Because AI analog input is meant for acquisition. Okay, and AO0 is meant for generation. Analog output will be generating, and analog input will be acquiring. Okay, so here what I'll do is I'll just connect from AI0 plus one wire to the another thing like AO0, and AI0 minus will be connected to AGNT. That is what I thought of writing here. AI0 plus to AO0 okay, and one more connection AI0 minus to AGNT. This is what a connection, like a loop back connection. We call this as a loop back connection. Why this loop back connection is nothing but to just check whether the analog port is working good or not. Okay. So similarly, if you want to use both the channels, so maybe you can just use AI1 plus to AO1 and AI1 minus to AGN. Like if at all you are trying to use zero channel in analog input, the same zero channel should be used in your analog output also. Okay, so 0 0 1 1. Okay, you should not try to connect from AI0 plus 2 and AO1. So it will be the different channel. So it's always better to use AI0 plus to AO0 and AI0 minus to AGNT. So since I have already made a connection, so what I'll do is, so here I have to select a channel name called AI0. So the mode I have just given as on demand. So since the input will be the differential part, so the maximum and minimum limit also they have already specified, plus 10 to minus 10. Right? So this is analog input where it will be acquiring the signal. Coming to the analog output, so this is where it is generating the signals or generating the voltage. So here I will be selecting DAC1 AO0 the voltage level mode will be the voltage DC. The same maximum and minimum input will be +10 to -10. Okay. So here the output level they have been specified. So first what I'll do, I'll just click on start. So you can just see some a random voltage. It's been recording here. Okay. So I'll just go to the analog output. Say here I'll just give 5 volt, and I'll just click on update. If you just see here, you're getting 5.01 voltage. Means whatever I'm just generating over there, the same thing will be acquiring back here. You can just see you're getting 5 volt. If I go here, if I give a 10 volt, and I'll just click on update, here you can just see here you're getting a 10 volt. Okay, so even you can just give a negative voltages also. If I give -3.5 and click on update, the same -3.5 volt will be recording here. Means it here you are generating. Here you are just trying to generate some sort of output. When I click on update, so the same thing will be recording here also. Okay, so now I'll be just showing you, if not you are not connected to proper grounding, means AI 0 plus to AJND, I'll just try to remove the connection, the ground connection. Okay, so when I try to remove the ground connection in analog output, I'll be just giving you some voltage like 5.3 on update. If you see here, the same 5.3 will be not acquiring the thing, but instead it is only acquiring like around 2.7, like half of its voltage, right? So, and here even though if you give 8 volt or exactly 10 volt, okay, so you're getting almost the 60% or 65% of the input whatever you have been given. So why? Because by not giving a proper grounding part. Okay, so if at all you just try to give any proper grounding part, obviously you will get a proper results. So here you're getting like around a -7, but the output whatever I have given was -6. Okay, so there will be no proper synchronization between the output as well as the input. Why? Because there will be a voltage drop while you have not connected a proper grounding section. Okay, so now I'll just try to connect a ground. Means AI 0 minus will be connected to the A ground. So maybe we'll be getting a proper voltage now. Yes, so I've been connected. So now I've given like -6, click on update. So if you go for analog input, you can just see the same -6 point will be updating. .3, so the same 6.35 voltage will be recorded. So now we can easily say that, so my analog input as well as analog output channel is perfect, and I am getting a proper output as well as whatever I provide a proper input here. Okay, so after checking this, I'll just click on stop. Okay, so now I'll just come back to the digital part. Okay, so where I have told you that each and every individual line will be the input or output. Okay, so here I'll just check the pin connections. So to where I have been connected. So I have been just connected a loop back. Okay, so that's what I told you. So I'll connect it to DIO pin number 0 to DIO pin number 4. This is one connection, and DIO pin number 1 to DIO pin number 7. So connected in this fashion. Why? Because the loop back test. Okay. So now we'll just see. Actually speaking, here I can just try to toggle between the input as well as the output. So here you are having totally 8 pins, starting from 0 to starting from 7. Okay, so this is first part will be the selecting the direction, and second part will be the state where you are going to check the output. I'll just click on start. So whenever I try to give pin number 0, okay, so you can just see I made pin number 0 as the input. Okay, means I'm writing input, in a sense we are writing. So when I just click on high, you can just see I have been connected from DIO 0 to DIO 4. Okay, so you can just see here DIO 4 will be, the LED will be glowing. Why? Because it's 0, 1, 2, 3, 4. Fourth LED is glowing now. Means I'm writing from pin number 0 and I'm getting the output in pin number 4. Okay. Similarly, what I'll do, I'll make this as the output. I'll make pin number 4. Pin number 4 as writing. So if I make pin number 4 as writing, you can just see in pin number 0 the LED is glowing. In the sense, you can just write from DAO 0 and read from DAO 4, and vice versa. Like pin number 4 you are writing and pin number 0 you are reading it back. Okay. So similarly, I've taken one more connection, like from pin number 1 to pin number 7. If I make pin number 1 as input, so you can just see pin number 7 is glowing. Means I'm writing from pin number 1 and reading from pin number 7. Or if I make pin number 7 as high, okay, so here you are not getting any output. Why? Because both at a time cannot be written, or both the pins cannot be read or write at a time. So it can be done any of one time. So now you can just see I made this as read. Okay, pin number 7 as write and pin number 1 as read, like vice versa. Fine. So I hope you have been understood here. So I think some little complications will be there, understanding in this digital line. So maybe I'll be clearly explaining you in some other part. We are having one more option called the soft front panel. So I'll be explaining you over there so that you can understand it much better comparatively to this. Okay. So this is what the thing, these DAOs have been designed in such a way that either it can be, write, or either it can be read, but not both at a time. Okay. So that is what the thing we are supposed to understand. Okay. So I'll just click on the stop. Okay. So I'll just close it. Good. So this is where you will be able to use like a test panels. Okay, like before getting into the hardware, first we have to know about the specifications. So after that, we have to test whether all the pins are and all the things are working good, like either power supply or DAOs or analog inputs, all these things. So then a later part we can able to just pitch into the hardware section, like what are the functions and what are the features of this hardware. So everything can be done in this. So may I know any doubts in this until now, sir? If anyone are having a doubt, maybe let me know so that I'll be just clearing all your doubts. Okay, so I hope no doubts. So maybe I hope everyone are understanding fine and good. Okay, so maybe I'll just try to continue the session. So may I know what is session timing, sir? Harish, sir. Hello, Harish, sir.
Oh, yes, sir.
Sir, may I know the session timings till what time the session will
Yes,
be?
sir. Another 10 minutes, sir. At 1, we'll close this session, sir.
At 1. So next session will be starting from
2 o'clock, sir. 2
from
to
2,
3:30.
2 to 3:30, right?
Yes, sir. Yes, sir.
Yeah. Okay, sir. Fine. No problem. Okay. So fine. So we have just understood, what are the applications and what is the features in the MyDAC. Okay. So now what we'll do is we'll just try to know about how to work with the hardware, like a connecting part or the things. So I have told you that if you just click on start after installing NI LVS MX 1900 or 1900 based on the LabVIEW versions what you install. Okay, so I have to just go to search and type Instrument Explorer. Okay, so or else you'll be getting NILV's MX Instrument Launcher. Okay, so if you just click on that Instrument Launcher, so you'll be getting this sort of the window, right? So where here you can able to directly access some sort of instruments like the ready-made instruments. Okay, so here you can just see we are having a board analyzer, arbitrary waveform generator, okay, function generator and oscilloscope, right? So digital multimeter can be accessed here, and audio equalizer also can be accessed here. Okay, so some readily made instruments have been available over here. Okay, so here first we'll just try to see about the digital reader and digital writer. Like I hope many of will be getting confused what I was showing in the test panels. So maybe I hope you people will understand here clear and betterly. Okay, I'll just double click on digital reader and digital writer. Okay, so here you can just see digital reader and digital writer. Okay, so where you'll be having some sort of settings or configurations. So according to that, if you just try to program it, okay, so the same thing will be going to reflect over here, right? So since I'll just open this. Yeah. Okay. So since I was showing the connections. Okay. So I have connected a wire like a loopback wire from DIO0 to DIO4 and DIO1 to DIO7. Okay. So now what I'll do is I'll just try to write from DIO0 and I'll be just reading it in DIO4. Okay, so DIO0 will be writing from writer and reader will be just indicate whether that particular LED is glowing or not. Okay, so here you can just see the options here where the configuration settings, you have 3 options in lines to write. So either you can choose 0 to 3 as a write or 4 to 7 as a write or entire 0 to 7 as a write. But if at all you select entire 0 to 7 as a write, there will be no pins or there will be no DIOs to read it back. Okay, so I hope you understood. And if you come for the same lines to read, okay, the same thing will be available 0 to 3, 4 to 7 and 0 to 7. But here, if at all you are trying to write from 0 to 3, the same 0 to 3 lines should never read it back. Why? Because it is been already configured for writing. So 4 to 7 will be meant for reading back. Okay. So now, so everything is been said. If you see here the device, Okay, so DAC, my DAC 1 NI my DAC has been connected. I have to select a DAC. Why they have been given this option in the sense, think that you can able to connect more than one DAC to your PC, like three DACs or four DACs. So if at all you are connected, you have to give a proper naming, and you have to check from this device you are reading and from which device you are writing it back. Okay, so these things will come to the picture. So if I'll click on run both. Okay, so if I make 0 as high, okay, in digital writer, you can just see in digital reader, pin number 4 is, lightening up. Okay, why? Because I have been connected from pin number 0 to pin number 4. Okay, so then similarly, if I click on DAO1, okay, here you can just see in digital reader, pin number 7 has been lightning. Okay, why? Because I have been connected a loopback connection. Okay, so here you are writing same. Similarly, if you see 3 and 4, none of the LEDs have been glowing in digital reader. Okay, why? Because I have not connected this 2 and 3. Okay, and similarly, if you see from 4 to 7, the whatever the switches I'm just toggling now, from 4 to 7 it is been disabled. Why? Because 4 to 7 is being meant for a digital reader, and this cannot be used for write options. Okay, so I'll stop now. So I'll just make the vice versa. Here the 4 to 7 should be write, and here 0 to 3 should be read. So if I give 4 to 7 itself and I click on run, okay, so it is showing me an error. Okay, so what is error? So request operation could not be performed because the specified digital lines are either reserved or device is not present in the NI DAC. Okay, so it is giving us a two option: either the system digital line is reserved or the device is not present in the NI DAC. Okay, so that's why it's always better to go with the vice versa option. Okay, so now if I click on pin number 4 toggle switch, so here you can just see line number 0 is been activating. Similarly, pin number 7, pin number 1 is activating, and 6 and 5 will be the dummy pins. Why? Because I have not connected any wires or any loopback connections to 6 and 5. So here the thing we must understand is the DAO can be used either to write or read, but not both at a time. That is what I know the ultimate thing will be. Right? So I hope you have been understood much clearly compared to the test panels. So if at all you people are having any sort of a doubt, you can just unmute yourself and you can ask the doubt, or maybe you can just drop your doubts in the chat box. So maybe I'll be just attending your doubts. Okay, sir, fine. So, I thought of, the starting a new topic. Okay, since we are having a very, shortage of time, maybe we'll just break for the lunch, and maybe like a post lunch, we'll just try to start with a new topic, and I'll be just demonstrating you about, the analog, digital, or I just try to use interfacing the sensors, and I'll be showing you the results.
Hello.
Yes, sir.
Sir?
Yeah.
Okay, sir. Then we'll end and we'll join at 2 o'clock, sir.
Yes. I have to use the same link, right, sir?
Yes, sir. Same link, sir.
Yeah. Sure, sir.
Okay, sir.
Thank you. Guys, we'll just try to break for the lunch, and we'll just try to get back for the 2 o'clock session. Fine. Thank you very much.
Yes, sir. Okay.